Hello, and welcome to GLISA's walkthrough of NOAA Atlas 14. Atlas 14 is an interactive tool that allows users to view location-specified precipitation frequency estimates in graphical or tabular form. The tool was developed by the National Weather Service's Hydrometeorological Design Studies Center and is managed by NOAA, the National Oceanic and Atmospheric Administration. This video is meant to provide additional guidance for potential end users in the Great Lakes region to help them navigate and better understand Atlas 14 and its applications. After the introduction, we'll explain how to use the tool, then walk through an example demonstration and interpret the tool's outputs. To begin, you can search for Atlas 14 in your browser and click on the first link, which takes you to the main page of the tool, the Precipitation Frequency Data Server, or PFDS. First, I'm going to briefly explain how to navigate and use the tool before moving into the more in-depth demonstration. You can view the state you're interested in by using the drop-down menu or by clicking on the state from the map. You will be directed to the Atlas 14 Point Precipitation Frequency Estimates page, in which we can see the state we selected, as well as the precipitation frequency estimates. These estimates are available to be viewed both as a table or as a graph. The curves displayed here are called depth duration frequency, or DDF curves, though you may know them by their more common name, intensity duration frequency, or IDF curves. The graph may be viewed as an interval or a duration curve, or on a duration of your choosing, along with the 90% confidence interval. Additionally, there is a third tab in which supplementary information in a variety of forms is provided. Next, we will explore the tool more in depth using a Great Lakes city as an example. You may specify the location you're interested in through latitude and longitude, station, or address. If I were interested in data for Ann Arbor, I might use the Ann Arbor station. You may also use the map and crosshairs to navigate to your desired location. Let's first scroll down to the table to look at the estimates for this location under the PF Tabular tab, which is displayed by default. Precipitation frequency estimates give the average recurrence intervals of precipitation depths for various durations. Columns correspond to different recurrence intervals in years, displayed at the top, and rows correspond to duration of events at different timescales on the left. The individual table cells contain the depth of precipitation in bold and the 90% confidence interval range in parentheses. These values provide an estimate of the average number of years between storms of certain volumes and durations. For example, 3.76 inches of rain falling within a 2-day time span is estimated to occur every 10 years. And 7.42 inches of rain falling within a 2-day time span is estimated to occur every 500 years. Precipitation frequency estimates can be downloaded in CSV format. You can select whether you want to download the estimates, the lower or upper bounds of the 90% confidence interval, or all. After I select all and then submit, the CSV file will be downloaded to my computer, where I can open it to take a closer look at the same information displayed on the table, or use it for my own analysis. Now we can view the same information in graphical form by clicking on the PF Graphical tab. There are two tabs within this, where the graphs may be viewed using interval or duration curves, or using a duration of your choosing. First, we'll look at the duration curves, which have two versions that show the same information in different ways. As we can see in the first or the top graph, the y-axis displays precipitation depth in inches, while the x-axis displays duration of precipitation events at different timescales. For example, at this location, 7.5 inches of rain from the y-axis, falling within a 2-day time span from the x-axis, is estimated to occur on average every 500 years, in correspondence with this teal-blue line identified in the legend. This is commonly referred to as a 500-year storm event. This is the average recurrence interval, but these values can also be interpreted as average exceedance probabilities. For this event, with an average recurrence interval of 500 years, There is a 1 in 500, or about 0.2% chance of precipitation exceeding 7.5 inches within a 2-day time span, at least once in any given year. A 100-year recurrence interval means that an event would have a 1 in 100, or a 1% chance of exceeding the estimated volume in a given year, and a 5-year recurrence interval would be a 1 in 5, or a 20% chance of exceeding in any given year. In the second, or the lower graph, the same information is provided in a different format, where the x-axis and the colored lines in the legend have been swapped. The x-axis now displays the average recurrence interval of precipitation events, and the lines correspond to the duration of precipitation events, just offering a different way of looking at the same information depending on user preference. For example, in this lower graph for a specified location, we can see again where 7.5 inches of rain from the y-axis intersects with a 500-year recurrence interval from the x-axis. A dark green line is displayed at that spot on the graph, which the legend tells us corresponds to a duration of 2 days. Next, we can click on the other tab of PF estimates with confidence intervals. This will show us the same thing as the graph that we just looked at, but allows us to only view one duration at a time, along with the 90% confidence interval, which may be easier to read and interpret than when all of the different duration curves are on the same graph. This graph still displays precipitation depth on the y-axis and average recurrence intervals on the x-axis. The lines are labeled by the legend, in which we can see that the black line represents the PF estimates, the red line represents the lower bound of the 90% confidence interval, and the green line represents the upper bound of the 90% confidence interval. This graph is interactive, and the duration of precipitation events can be changed using the options on the left side of the graph. If we take our same example, and again select a 2-day precipitation event duration, we can see that about 7.5 inches of rain falling within that 2-day time span is estimated to occur every 500 years. If we select the 60-minute precipitation event duration, we can see that 2 inches of rainfall falling within a 60-minute time span is estimated to occur about every 25 years, with the bounds of the 90% confidence interval being 10 to 50 years. Supplementary information is available for temporal distribution of heavy precipitation, analysis of seasonality, cartographic maps of precipitation frequency, spatially interpolated precipitation frequency estimates in GIS format, and watershed information. Atlas 14 is a useful tool to examine and understand precipitation frequency estimates for a specific location. I hope that this was a useful walkthrough and that this video helped you better understand how to use Atlas 14. This video was created by GLISA, a climate adaptation partnership team funded by the National Oceanic and Atmospheric Administration, dedicated to helping the Great Lakes region build lasting and equitable climate resilience. This is one of several tutorial videos intended to help make climate, weather, and coastal resilience tools more accessible to end users in the Great Lakes region, under a project funded by Michigan Sea Grant. There are also accompanying guidance documents available for each of the tools covered in these tutorial videos, available at this link, which is also in the video description. This video and accompanying guidance document were created for educational purposes only, and are in no way affiliated with the NOAA Atlas 14 tool or its developers.